Hello and welcome to SudoKanard. After a few videos with crazy difficult Kakuro puzzles, I've decided to settle down and tackle some other arithmetic puzzles, and namely I've chosen TomTom. And I found somewhat easy puzzles on Grandmaster Puzzles website, and I've chosen two of them. So the first one is by Eric Fox. And first, I just recall what the rules are. So this is a 6x6 grid, so we have to put digits from 1 to 6 so that they form a Latin square, meaning that each digit should appear exactly once in each row and in each column. It's not Sudoku because there's not the constraint that additional region contain those digits exactly once. And then you see the results of operations. So these regions look a little like Kira Sudoku, but it is not Kira Sudoku because digits are allowed to repeat in those bent regions. Now, the clues are quite straightforward. This means that the product of all digits in this region must be 20. The sum of all digits in this region must be 18. And when you see a division symbol, it means that the biggest digit divided by all of the other digits must give here 1. So I think that's about it. I've reproduced the reference timings, the time standards that are to be found on Grandmaster Puzzles, so it should be fairly easy. Now, before I begin, I just state the fact that the sum of all digits from 1 to 6 is 21. So it allows me to place a 4 in this digit, a 4 in this cell, and a 3 in this cell to complete those full sums in those columns. Obviously, this is a 5, and this is a 5 as well. Now there's a difference of 1 here, and this can't be a 5, so this has to be a 3. This 20 product means it's a 4 and a 5, and because of this 5, it's 4 here, 5 here, same in here, 4 times 5, and this 5 disambiguates the lots. Now, those 5s give us the presence of a 5 in one of those cells and in one of those cells. And we now know that no 5 is to appear in those cells. Now there's a division by which yields a 3. Exactly 2 such divisions work, 6 divided by 2 and 3 divided by 1. But 3 is not available, so they have to be 2 and 6 in some order. And only 1 remains in the row. These digits should be consecutive. This one is not a 4, so it has to be a 2. Now, a difference of 3 is either 6 minus 3, 5 minus 2, or 4 minus 1. And 2 and 3 are already used, so only 4 and 1 fit in those cells. And the 6 completes the row. Now, where should we look? We need 6, 3, and 1 in here. 6 can't go here because it would require a 5 here. So there's a 6 somewhere in there. And this is 3 or 1. So this has to be 4 or 2. And now there's a 6 with 3 and 1. And there are 2 possibilities. One of them is to have 6 here and 1 and 6. And let's check. It puts a 3 in here, 6, it's a 2, a 4, a 1 and a 3. That works. Or we have 6 and 3 and it puts therefore a 2 in this cell. If we put 6 and 3 in here, this is a 2. And now we have a 6-2 pair, making this a 4 and this a 3. So it's actually 6 and 1. Oh, sorry. It's actually 6 and 1, and this has to be a 6. Let's clean up. That's a 1, that's a 4, that's a 2, that's a 6. And this is a 3. In here, we need 2 consecutive digits without using 3 or 6, and without using 5 or 4, so they have to be 1 and 2. Now, in this row, I need to place a 4 somewhere, and 4 can't go here, so 4 has to go here, and we can fill in the remaining 5s. We need a 3 in this column. It's not here, so it has to be here. We need to put a 6 somewhere in here. So to fulfill this division, it has to be 6 and 2. So this is a 1. And this is a 2. A 1 in here. We now need a 6 in this row. It's not here, so it has to go here. And the rest is... Oh, sorry, that's a 3. The rest follows automatically. So that was nice puzzle. Actually, I didn't know that Eric Fox did something else than Sudoku. And I'm glad that he does, because he's really a very good constructor. Now on to the second puzzle. This one was compiled by Murad Jamtonta, who's a very famous author on Grandmaster puzzles. It was actually his 167th puzzle on this website. And this one is supposed to be even easier if you see the standard timing, and it may come as a surprise if you consider the fact that no operations are specified. But you can see that 100 is obviously multiplication, as well as 60 and 24. Those have to be multiplications because any other operation can't possibly yield such a big result. And something amazing is this region without a result. And it's called timekeeping, and I can see why. There's a 24/7 here, and those 60, which 60 is a very important number in considerations of time. 60 minutes in an hour, 60 seconds in a minute, 12 hours on the clock. Okay, 4 seasons. Let's start solving this. This 7 can only be a sum, because subtraction would be 6 minus something. It wouldn't reach 7, and no multiplication of digits between 1 and 6 could produce a 7. And those have to be 1, 2, and 4. 24 can only be done with 4 times 6. This 100 can only be done by, well, it should be this or that, but only 1 digit can be repeated. So 2 by 2 is not possible, so it's 4 by 1, and this cell is a 5. This 60 product must include a 5, but it can't be here or there because of this 5, so it has to be here. And this 60 product needs a 5 as well, and this 5 puts it in there. Now we need another 12, which 12 is either 2 times 6 or 3 times 4. But we know that 4 is bound from both cells, so it has to be 2 times 6, and 2 is bound from here. So this is a 2, that's a 6, and 3 and 4 go in those cells because of this 2. Now, in this column, we need a 1 and a 3, but 3 can't be in a 100 product, so that's a 1, that's a 3. We now need, we don't know whether this is a sum or a product. It could actually be either one. It could be the sum of 5, 4, and 3. It could be the product of 1, 4, and 3. And I think these are the only options. Yes, a 6 wouldn't fit. Yes, these are the only options. So 5 plus 4 plus 3, or 1 times 4 times 3. In any case, there's a 4 in there, so I can remove this 4. And, by the way, there's a 3 up there. So now we know there's a 4 in here and a 4 in here. So we already have 2 4s for these two rows. So there are no other 4s in here. I just state there are 1 and 6 in those cells. And, I fill in this and then I go back to this. I need now 4 and 5 doesn't go here, so that's 4, 5, 2, 6, 2, 6, and this 4 fixes this 3, 4 cell. 3, 4 pair, sorry. Well, I was saying something about 4s in here, but now those 4 tell us that these don't include a 4. So this is neither a multiplication nor a division. It has to be a sum, addition, 1 plus 3, or a subtraction, 6 minus 2, or 5 minus 1. And at this precise moment, both seem possible. But I know now that 5 doesn't go here, so this is actually 1. It's the product 1, 4, and 3. And it makes this a 2, removing the 2's from up there. Those digits must be 2 and 6, meaning that this can now only be 6 minus 2. So this is a 6 as well. This is a 4, that's a 6, that's a 1, that's a 4. Those digits must be 5 and 3, and because of this 5, that's a 3, that's a 5. 5 and 6. Remove his 6 from those cells. That's a 6, that's a 6. Those cells must be 4 and 3, and this 4 makes this a 3, this a 4. I didn't clean up with this 6. That's a 2, that's a 6, that's a 2. 1 and 3 in this column, because of this 3, that's 1, 3, 1, and 2, which wraps up the solve of this very nice TomTom without any operation specified by Muratjan TomTom. Well, there's something to be said about this website, Grandmaster Puzzles, and it's that every single one of the puzzles you find on this website is absolutely excellent. It's not necessarily very challenging, but it's very fun to solve. All of them. Well, the ones that I managed to solve anyway. So thanks for watching this video and see you soon, see you later on SudoKanard.